Okay, so we got another question from normal distribution. So this question, it says the weight in grams of pineapples is denoted by the random variable x, which has a normal distribution with mean 500 and a standard deviation of 91.5. The pineapples weigh over 570 grams are classified to be large, and those weighing under 390 grams are classified as small, and in between 390 and 570 those pineapples are classified as medium. So it's three different sections. They want you to find the proportions of large, small, and medium pineapples. So what it means is we need to just find the probability of x less than 390. That gives the proportion of small, and x greater than 570. That gives the proportion of large, and then if you subtract this from 1, the total probability, we shall get the medium proportions. So then there's another part of the question which I'll be moving on later. So to begin with, let's say x is the weight of the pineapple. So x is normally distributed with a mean of 500 and a standard deviation of 91.5 square. So here's the normal curve. We got an average of, this is for x, not the standard normal, it's not the standard normal deviation, not the standard normal table, and the mean is 500, and over here I got 390, and over here I got 570. So the section which is shaded in green, sorry, so this is large, and then this is small, and in between we got, all right, so now I hope we understand this part is large, this part is small, and this part is medium. All right, so let's get into the proportion of large. Probability of x greater than 570. This shall be normalized as z greater than 570 minus 500 over 91.5, which gives you a value of z greater than that's going to be 0.765, so which is 0.77. So this is 1 minus probability of z less than 0.77. So let's check the normal table. 0.77 is 7794. Therefore, this is 1 minus 0.7794, which is 0.2206 is the proportion of large. So this is the proportion of large pineapples. And next, let me get back to the small pineapple proportion. That shall be x less than 390. So this is probability of z when you normalize this, 390 minus 500 over 91.5. So this one is going to be probability of z less than 390 minus 500 over 91.5, and that is going to be minus 1.20. So when there's a negative probability and z less than minus 1.20, that is equal to 1 minus pz less than 1.20, because this area is same as this area. This is 1.20, this is minus 1.20, and this area is 1 minus the rest, so 1 minus the rest. So that's the reason. So 1 minus 1.20 is 8849. So let's take that, 0.8849. So that is 0.1151. This is the proportion of small. And then we can take 1 minus the rest. So proportion of medium shall be 1 minus 0.2206 minus 0.1151. So that's going to be 1 minus 0.2206 minus 0.1151, which gives you a value of 0.6643. So that's the proportion of median. So we got all three, and that's the working for part I. And now we need to move on to part part 2. And here they say find the weight exceeded by the heaviest 5% of pineapples. Let's say the cutoff mark for the heaviest 5% of pineapples is simple A. So probability of x greater than A shall be 0.05. So I can simply use, if this is my normal table, if this is 500, if this is A, this percentage should be 0.05, or this percentage should be 5%. That's the heaviest 5%. So probability of x greater than A shall be 0.05. So when you normalize this, z greater than A minus 500 over 91.5 shall be 0.05. I can use the standard normal table with the small table, we call it. So here we got the greater than probabilities, as you see, z greater than probabilities, and here 0.05 corresponds to 1.6449. So I'm going to use that value as my z value. So A minus 500 over 91.5 is equal to 1.6449. So 1.6449 into 91.5, and this value plus 500 is equal to 651 to the nearest whole number. So A is equal to 651. So that's the working for part B. Now next, let's move on to part C once again. So it says find the value of k such that probability of x lying between k and 610 is 30%. So that is interesting because 610 exceeds the mean. So if you take this as 500, here is 610, definitely k should have been somewhere in between. So this part is what they say is 30%, 0.30. So let's take this as it is. K less than x less than 610 is 0.30. So probability of x less than 610 minus probability of, and also we need to check to be more specific about this question. We need to make sure whether k is less than 500 or more than 500. For that, if we can find the area of this part which is between 500 and 610, and if that area or that strip doesn't exceed 0.30, then we can make sure that k lies less than 500. Otherwise k also should be more than 500. Now let me check the standard normal table. 610. So over here, probability of 610, let me explain this separately, the working. So over here, probability of x less than 610 corresponds to probability of z less than 610 minus 500 over 91.5, which is z less than 610 minus 500 over 91.5. This is 1.20. This is 1.20 once again. So probability of z less than 1.20 is 8849. So that is 0.8849. So from 0.8849, you know, this entire area, this part becomes 0.50, this whole thing. So if this part is 0.8849 minus 0.5, that becomes 0.3849. So that means K should lie between 500. K should lie between 500. So here it is. So now we can work it out. Probability of x less than 610 minus probability of x less than k shall be equal to 0.30. So z less than 610 minus 500 over 91.5 minus probability of z less than k minus 500 over 91.5 is equal to 0.30. As you know, we just found this value, that is 0.8849 minus z less than k minus 500 over 91.5. This is equal to 0.30. Therefore, I can say z less than k minus 500 over 91.5 shall be equal to 0.5849. Now let's check the normal table once again. Where do you find 5849? We have 5832 at 0.21 and 5871 at 0.22. So I should pick 0.21, which means k minus 500 over 91.5 should be 0.21. So we get k equals to 0.21 into 91.5 plus 500, which is equal to 519 to the nearest whole number. So k is equal to 519. So that's it. That's all in this question. Hope you understood.